10, Lesson 5, we're going to talk about sample means. So one thing about math that's generally really cool is our titles mean exactly what we're doing. So mean is average. And since it's plural, we're going to talk about averages, more than one. Well, what averages are we going to talk about? Averages we get from samples. So in the classic experiment that most of you know, 2 or more treatment groups are randomly created. We like to put that word randomly in. Therefore, we signify that we totally assigned people to 2 different groups randomly. There was no prior knowledge. And then we subject the different treatments. The question is then determined if the variability seen between the 2 groups is due to the treatment, or did it just occur naturally? So let's look at that a little further just with the words. So exercise number 1. Suppose we started with 50 people and we're going to try out a new diet pill that will help increase weight loss. The people are randomly divided into 2 groups. One is given the pill and the other is given a placebo. A pill designed to look like the real one, but it doesn't have any medicine in it. It usually just has some sugar in it. There are 2 main variabilities that can be introduced to the results, and we're going to discuss each. So you have your groups. You have, let's do it down here. Let's have our 2 different groups. One group gets the pill, and the other group doesn't get the pill. Induced variability created because the treatment of the subject was placed in. So we induced the triangle and the, what is this? Hexagon. We induced that. We want the people who took the pill to lose weight. We induced that pill so that we can see that this group loses more weight than the second group. We induced that. Now, at the end, we go and we study our results. But we have to be careful because, well, maybe our pill didn't have an effect. Different people have different metabolisms. I've said it. My husband can give up sugar and lose 15 pounds. I give up sugar and I gain 3. Some just may exercise more than others. Some will eat more than others. So there's all these other natural variability that people have and they act differently. And it's hard to control every variable so that all we have is just the pill making the difference. So let's look at a different one. A seed company is trying to determine the effect of synthetic nutrients. Synthetic nutrients means we made the nutrients in a lab versus organic nutrients. So organics are, something on your own. So for example, my garden I just planted, I put a compost down on it. We've been composting all our vegetables and eggs over the winter, throwing it in, making a nice big rich soil. So that would be organic nutrients. Synthetic nutrients would be, I go out and I buy a Miracle Grow and I put that on my plants. And now we're going to study the growth rate of corn plants. They select 40 seeds randomly and distribute the seeds into 2 groups of 20. So basically, this is what happened. We have 2 seeds. One goes in one group, one goes in the other. So we're randomly picking seeds out of this bag. And there they go. We're randomly putting them into 2 groups. And each group, there's going to be 20 seeds. We plant those seeds and then we watch them grow. Group 1, green for organic, these are the heights. And the group red, the synthetic, these are the heights. So now we're going to compare and contrast. One way to do that is to look at a box and whisker. So right here, I have the red and the green. So I decided to compare these, to take the sample and compare their averages. In this case, I decided not to look at averages, but I decided to look at their medians. So the green one, the shortest guy, only grew a whopping 6 centimeters. And this piece of corn grew a whopping 25 centimeters. If I were to overlay the synthetic group with the red group, with the green organic group, there I overlaid them. Doesn't it look like the red group grew more than the green group? Our median is 18 for the red, and that was the third quartile for the green. So now we have to ask ourselves, okay, did our synthetic nutrients really have that effect? Or was I just lucky when I divided out those seeds and I happened to pick 20 seeds that came originally from a really strong flower or a really strong plant? So I would run this experiment multiple times to see if I got the same results every single time. Did every single time the synthetic be higher than the organic? Who knows? But this is just one sample. So, what are we getting at? After establishing a sense of full distribution, if the observed difference of an experiment is extreme, far from zero, and not typical of chance behavior, it may be considered statistically significant and possibly not the result of chance behavior. So, in other words, let's go back here. And did we just get lucky with this red group? Did these seeds just happen to be a really good group of seeds? Or was it statistically significant, meaning that those nutrients really did play a difference? We don't know until we run multiple samples. If the observed difference is extreme and not typical of chance behavior, it may be considered statistically significant and possibly not the result of chance behavior. That means, hey, if all the time we're getting really great growth rate, sample upon sample upon sample upon sample, then guess what? It's not chance. We're on to something. If the difference is not the result of chance behavior, then maybe the difference did not just happen by chance alone, right? That's what I just said. If the difference did not just happen by chance alone, maybe the difference you observed is caused by the treatment in question. In the context of our example, a significant difference value provides evidence that the nutrients did in fact yield better seeds on average.